All right, number 11, we're sitting on a bike at rest, and brother comes running up behind, speed of 2 meters per second. I start my bike, and let's just kind of draw a picture of the situation. So here I am on my bike. This is going to be a really bad drawing. So here's my attempt at drawing a bike. And then I'm going to draw the brother here. They're going at 2 meters per second. I'm going, and that's my brother initial speed, and then I'm at 0 meters per second. That's my initial speed. I'm going to say that the initial position of my brother is 0. My initial position is also, you know what, I'm going to use different colors. Let me just start this a little bit more carefully. So my brother's here. His initial speed is 2 meters per second. His initial position is 0. And then I'm on a bike. I'll just draw the bike and I won't draw myself. That's a really bad drawing. So my initial position is 0. My initial velocity is 0. My initial position is 0. My acceleration is 2 meters per second squared. This is at t equals 0. Again, his acceleration is 0. T equals 0. And that's here, and then yeah, that's it. That's a good start. So what time do I have the same speed as my brother? So let's just see. Let me write down an equation for me and an equation for my brother. So my equation is going to be v equals at plus v naught. And my brother simply has a speed v naught equals 2 meters per second. And we want to know when these two are the same. So I can actually say 2 equals my acceleration, which is 2, times t plus starting at a speed of 0. So that happens at 1 second. Now, what time do I pass my brother? So let's write down the equation for my brother's motion. That's going to be x of my brother is v naught t plus x naught for my brother. So that's going to be x equals 2 times t. And for me, my equation is going to be x is 1/2 times 2 times t squared plus 0 plus 0. So my equation is x equals 1 is just t squared. And I want to know when those two things are going to be the same. So I need to set t squared equal to 2t. One of the t's cancels, so I'm going to get that t is in fact 2 seconds. Notice the other answer is 0 seconds. That's when we kind of first start. Now, the position versus time, I'm going to just sketch a graph of how this is going to look. So here I am sketching position versus time. So my brother's graph is just going to be a nice linear function like this, whereas I start off at the same position and then I accelerate to catch up to him. And this would be 0 seconds, and right here is going to be 2 seconds. Right here, by the way, at 1 second, just notice, if I were to draw a tangent line right here, the slope at 1 second should be the same here and here. They should actually have the same slope. For those of you in calculus AB, it's because right there, since they have the same speed, the derivative of the parabola here is a line. That tangent line slope should be the same as the slope because they have the same, the instantaneous velocity here is the same as the constant velocity here for the brother versus and the bike. All right, and then the velocity versus time graph is going to, let's actually sketch that. So for the brother, it's just going to be a flat 2 meters per second. And then we're going to notice that they actually intersect at 1 second. When I draw my graph, I should have the velocity versus time for me intersected at 1 second, just like we calculated. And that is question number 11.